Welcome so much to this next video, guys. Today we're going to be talking about the issue of time. And our learning goal is that students would make sense of time duration in real applications. And you've got a couple of objectives here by the end of this. That you'll be able to solve problems involving duration of time and convert between different units of time. All right, dilate that time. You might have seen the movie Interstellar, and in it there's a particular planet they go to that when they land on the planet, time for them appears faster than for other people. For example, the guy sort of orbiting around in his spaceship, and it's actually a real thing. If we consider Einstein's theory of special relativity. Actually, it's not special. It is of general relativity. General relativity. Okay, so this theory of general relativity sort of goes into the idea that in the presence of mass, space-time warps. Okay, so even the space that we kind of see around us, it actually warps because there is too much mass there. And what happens is that the closer you are to a center of gravity, the faster your time is going to work than someone who's further away. Okay, and so for example, if this has been actually demonstrated here on Earth, in that if here's you on Earth and there's someone flying past in the weirdest shaped airplane you've seen ever. Alright, there they are. They're hanging out in there in their airplane, flying around the world. Okay, their time is slower in comparison to you. Okay, down here. Okay, but it is only slower in comparison. Both you and the person in the plane both think that your time, that their time themselves, is the correct one, and the other person has the wrong time. Okay, it's just this bizarre effect of the way everything has to bend and warp and go crazy just to make it so light, the speed of light stays the same for everyone who's looking at it. Okay, so it's a really interesting effect. Very weird one, but totally true. So time is relative. However, we're going to be sort of talking about how we can calculate things with time. And it's okay because as far as the Earth is concerned, we're all spinning around at about the same speed and all sitting on basically the same sort of gravitational point. So we're going to be okay. All right. Let's scroll down and have a look at some of our key ideas. So the standard unit of time is the second. Okay, so the abbreviation for it is just S. Okay, so just be careful with that. You might be wanting to put SEC or something, but just go with S. It's all you need to do for seconds. And similar to the way we've been able to convert between different amounts of distance, we can also convert between different units of time. Okay, so there's 52 weeks in a year, there are 7 days in a week, and there are 24 hours in a day, and there are 60 hours in a minute, and there are 60 minutes in an hour, 60 seconds in a minute. Okay, and similar to the way we've seen it before, when we're going from years to weeks, you're going to multiply when we're going this way. Okay, multiply, 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 and we divide when we're going back up this way. Okay, now one of the more particular type of calculations you want to try and remember is that the one to go from hours to seconds. Okay, so this way would be times by 3,600. Okay, because there are 3,600 seconds in an hour, and obviously going back the other way, you would divide. Okay, so that's a good one for just a nice round one for you to consider, because that's something that happens a lot, having to convert between hours to seconds and things. Okay, all right. So we use the abbreviation AM, which is Latin for ante meridiem, which means before midday to describe the 12 hours before midday, and PM, which is post meridian for the 12 hours after midday. Okay. It's a particular type of time called 24-hour time, shows the number of hours and minutes after midnight. Okay, so if it's 03:15, that is 3:15 a.m. Okay, because it's like, so this part here is the hours and this part here is the minutes. Okay, and 17:45 is 5:45 p.m. Okay, because it would be 17 hours after midnight. 17 hours through the day is would be 5 o'clock in the afternoon. Okay, right. So the Earth has been divided into 24 different things called time zones. Okay, now we won't have to worry too much about this idea at grade 8 level, but it is something good for you to know. So time is based on the time in a place called Greenwich in England, and it's called Coordinated Universal Time, UTC, or Greenwich Mean Time, GMT. Okay, so you might know that Australia is +10 GMT, which means that we are 10 hours ahead. Well, not Australia necessarily, Brisbane, our time zone. We are 10 hours ahead of Greenwich. Okay, and here's our 3 time zones here. So we have Eastern Standard Time, EST, which is 10 hours ahead, Central Standard Time, which is 9.5 hours ahead, and Western Standard Time, which is 8 hours ahead. But what's more to the point there is that something that's probably more important for us is that we are half an hour ahead here in Queensland than, say, in South Australia and Northern Territory, which is the Central Standard Time. And we are 2 hours ahead of Western Australia, which is our Western Standard Time. Okay. There's not a lot of examples that we can sort of go into, because a lot of the stuff looking with this time stuff just to be converting between different units. You've probably had experience in that already this year or in previous years, and so it's just about getting used to switching between the different units and maybe mucking around with a little bit of stuff to do with time zones. Okay, so thank you so much for watching.